Do you have difficulty with math? Worry no more, because I have a solution for you. Let's have math classes with Mamshi. See you in class! Our topic is about asymptotes of rational functions. The objective is, at the end of this discussion, the students will be able to determine the asymptotes of rational functions. So what are asymptotes? Those are the straight lines associated with a curve such that as a point moves along an infinite branch of a curve, the distance from the point to the line approaches zero, and the slope of the curve at the point approaches the slope of the line. So take note of this word approaches zero. It means that the distance from the point to the line may approach or become nearer and nearer to zero, but it will never meet zero. We have also here the example of our asymptote. This pink line here, this one is a vertical asymptote, and this red line here is our horizontal asymptote. Take note that no matter how near this line or this graph of a rational function is, it will never touch our asymptote. Also, we have here an example of an asymptote. This one is a vertical asymptote and the other one is the slant asymptote. So later on, we will discuss how to find the asymptotes of our rational function. Simply, an asymptote is a line that the graph of a function gets close to but does not touch. So I have prepared a hugot line here for you. Alam mo, para lang tayong asymptotes. Bakit? Kasi kahit anong lapit ko sa'yo, hindi pa rin kita ma-reach. O diba? That is how we define our asymptote. No matter how they become near to each other, they will never ever reach each other. Let's continue with our discussion. What are vertical asymptotes? These are the restrictions of the domain of a reduced rational function. To find the restrictions equate the denominator to 0 and solve for the value of x. And also, take note that the factors that are cancelled when a rational function is reduced represent the holes in our graph. How about our horizontal asymptote? It is determined by comparing the degrees of the numerator and the denominator of the rational function. So, what do we mean by degree? When we speak about the degree of a polynomial, it means that it is the highest exponent of the variable. Again, the degree of a polynomial refers to the highest exponent of the variable. Now, let n be the degree of the numerator and m be the degree of the denominator. So we have here the conditions. If n is less than m, then the line y equals 0 is the horizontal asymptote of our rational function. Next, if n is equal to m, then the line y equals a over b is the horizontal asymptote, where our a and b are the leading coefficients of the numerator and the denominator. When we speak of leading coefficients, those are the numerical coefficients or the number that is attached with our variable. And so, lastly, we have this last condition. If n is greater than m, then the graph has no horizontal asymptote. If it has no horizontal asymptote, then it has an oblique or slant asymptote. It occurs when the degree of the numerator is greater than the degree of the denominator. And how to find this? If you divide the rational function with long division or synthetic division, this kind of asymptote is the quotient with the remainder ignored and set equal to y. So here is an example of an oblique or slant asymptote. So let's have these examples. Number 1, f of x equals x minus 4 all over x plus 4. How are we going to find our vertical asymptote? Note that we have to equate the denominator to 0 and find the value of x. So this one is our denominator, so let's just equate that to 0. X plus 4 is equal to 0. Therefore, x is equal to negative 4. X equal to negative 4 is the line that would be our vertical asymptote. Let's continue. How about our horizontal asymptote? Take note that we have to identify the degree of the numerator and the denominator. So, with this one, this is understood as x raised to 1. Therefore, the degree of our n is equal to 1, and also the degree of our denominator is also equal to 1. Therefore, we can say that n is equal to m. Since they are equal, therefore, our horizontal asymptote will be y equals a over b, where your a is the leading coefficient of the numerator and b is the leading coefficient of your denominator. Take note that the number that is here is 1. This is understood as 1x. And also below here in the denominator, it is also understood as 1x. So that is equal to 1 over 1. And 1 over 1 is equal to 1. And so, our horizontal asymptote is a line y equals positive 1. Let's try to check out this graph. This line passing here, the pink line is the horizontal asymptote. It is really y equals positive 1, and also this standing line here, which is in blue, is our vertical asymptote, and it is really x equals negative 4. Let's continue with our example number 2. Let's find the vertical asymptote. So all we have to do is equate the denominator to 0 and find the value of x. So we have the denominator x plus 3. Equate that to 0, and so our x is equal to negative 3. This will be our vertical asymptote. The line x equals negative 3. Let's continue by finding the horizontal asymptote. Take note that the degree of our numerator is equal to 2. And the degree of the denominator is equal to 1 because that is understood as x raised to 1. On this case, the degree of the numerator is greater than the degree of the denominator, and so it has no horizontal asymptote. If the graph has no horizontal asymptote, it is stated that we only have the oblique or slant asymptote. Sorry, that's slant. Okay, so how do we find the slant asymptote? It is stated that we have to divide the rational equation. So let's try to divide this. X squared minus 5x plus 6 divided by x plus 3. Remember that when we divide polynomials, we have to start first with the first term. So that's x squared divided by x. x squared divided by x, the answer is x. And x times x is equal to x squared. Next, x times positive 3 is equal to positive 3x. And so, just like any other divisions with a regular number, we have to subtract this part to our new product here. So x squared minus x squared, we got 0. And negative 5x minus 3x, we get negative 8x. Then bring down your positive 6 and continue dividing. Negative 8x divided by x, the answer is negative 8. So, negative 8 divided times x, we have negative 8x, and negative 8 times 3, we have negative 24. So, if we are going to subtract them, we have negative minus negative 8, that is equal to 0, and positive 6 minus negative 24. So, it's like this. Negative 8, that will become positive, and so you have to add them. It becomes 0. So, 6 minus negative 24 will have positive 24 and add them. So, we have positive 30. So, our remainder is 30, and this quantity will be ignored. Only thing that we have to notice is your x minus 8. Therefore, our slant asymptote is y equals x minus 8. We don't have a horizontal asymptote in this case, but a slant asymptote. Let's try to check the graph. Okay, this pink line here is y equals x minus 8. This is really our slant asymptote. And also, the vertical asymptote is x equals negative 3. This blue one. It means that finding the vertical and horizontal asymptote will guide you in graphing your rational functions. Let's continue with our example number 3. F of x equals 5x minus 3 all over x plus 3. So finding the vertical asymptote, we should equate the denominator to 0 and find the value of x. X plus 3 equals 0. And so, we have x equals negative 3. This will be our vertical asymptote. Now, let's find our horizontal asymptote. The horizontal asymptote, in finding the horizontal asymptote, we should compare the degree of the numerator and the denominator. On this case, the degree of the numerator is 1, and the degree of the denominator is also 1. So, n is equal to m. And therefore, our horizontal asymptote will be a over b. What is a here? We have 5 over b, which is 1. Therefore, our horizontal asymptote is y equals 5. That's the line y equals 5. So let's check out this one. This pink line is our horizontal asymptote. It really passes y equals 5. And our vertical asymptote is x equals negative 3. This one, the blue one. And so it really passes with x equals negative 3. Let's have our last example. 4 equals f of x. Number 4, f of x equals 2 over x plus 1. So, in order to find the vertical asymptote, we have to equate the denominator to 0. So, x plus 1 equals 0, and so x equals negative 1. X equals negative 1 is the line for the vertical asymptote. Next, let's find our horizontal asymptote. Take note that the degree of our numerator is 0. We don't have any variable there, so the degree of our numerator is 0, and the degree of our denominator is equal to 1. Notice that the degree of the numerator is less than the degree of your denominator. And so, our horizontal asymptote is the line y equals 0. Or this refers also to our x-axis. Please try to check this out. Your blue line here is the vertical asymptote and it really passes your x equals -1. And this one, this pink line, is also the same as your x-axis. And that is your y equals 0. So I hope that you've learned a lot from our discussion in finding the horizontal and vertical asymptote, as well as the oblique or slant asymptotes. This will really help you, or these ideas will really help you in graphing our rational functions. See you in our next class. Thank you and goodbye. For those who are new to my channel, just subscribe to my channel, click subscribe, and hit the notification bell to be updated of my latest videos. Thank you for watching, and I hope you learned a lot from me.